So in this video we can see an example related to linear independence. That is, you will be having some set of vectors belonging to some vector space V. You need to find the lambda linear combination, that is lambda 1 V1 plus lambda 2 V2 plus lambda k Vk will be equal to 0 vector. Solve it for lambda 1, lambda 2, etc. lambda k. If the lambda values, any one of the lambda values, it gives us 0, then we can say that it is linearly dependent. And if all of the values, that is lambda 1, lambda 2, etc. lambda k equals to 0, then it will be called as linearly independent. So keeping this logic in mind, we need to solve for the example problem. So if, for example, we will be consider over here 3 vectors 1 minus 3 2 1 minus 1 2 2 5, then 2 minus 2 minus 3 3. Okay, these are the 3 vectors. So linear combination will be like lambda 1 vector 1 1 minus 3 2 1 plus lambda 2 vector 2 minus 1 2 2 5 plus lambda 3 vector 3 2 minus 2 minus 3 3 will be equal to a 0 vector. Okay, so from this itself you will be able to know that there are 3 unknown variables, and the 3 unknown variables, if all are equal to 0, then the given set of vectors, they will be linearly independent. If any one of the lambda variables it is not non-zero value you are getting, means it is a linearly dependent vector. So for that you can write this linear combination into a matrix form, like combining all those vectors 1 minus 3 2 1 minus 1 2 2 5 2 minus 2 minus 3 3 lambda 1 lambda 2 lambda 3 will be equal to the 0 vector. Okay, so from this you need to find the value for those unknown variables. So here we are having 4 equations, 3 unknown variables, and right hand side it is equal to 0. So for first what you need to do, you need to convert this matrix into row echelon form. So in order to convert to row echelon form, what you need to do, you need to perform the row operations. So once again consider the matrix 1 minus 2 minus 1 2 minus 3 2 minus 2 2 2 minus 3 1 5 3. Okay, now what perform the operation like, so this is the pivot, that is a leading non-zero value. Here it is 1, so that can be considered as a pivot. Now you need to make the below elements as 0, and also the diagonal elements can be made as 1, so that it forms a row echelon form. So in order to make this value as 0, you need to perform the operation like R2 is equal to 3R1 3R1 plus R2. Okay, so you will be getting the matrix as 1 minus 1 2. After doing the operation you will be getting 0 1 minus 4, that is 3 into 1, 3 minus 3 is 0, then 3r1, that is minus 3 plus r2. Minus 3 plus 2 is minus 1, and again 2 plus 2 is 2, sorry, 3 into r1. Here minus 3 it will be getting. Okay, so minus 3 plus 2, you will be getting minus 1 over here, and again 3r1 means 6 plus r2, that is minus 2, you will be getting 4 over here. Okay, so here this value can be made as pivot. So for that you are just negating the value, negating this operation. Negating this operation, you will be getting what? Plus 1, and here minus 4. Okay, so this is how you will be getting that value, and then 2 2 minus 3 1 5 3. So now this is a pivot element. So in order to make the pivot element, make this value as a pivot element only, we are negating that entire operation. Okay, now you can, now the R2 column, it is R2 row, it is okay. Now you need to consider the R3 row. So R3 row can be written like R3. So you need to make it, this value need to be made as 0. So R3 can be written as 2R1 minus R3. Okay, so the matrix can be written like, first two rows you can write like that itself, 0 1 minus 4, and the third row will be like 2R1 2 minus 2, it will be equal to 0. Again 2R1 minus 2 minus 2, it becomes minus 4. 2R1 4 minus 3 will become 7. Okay, then 153 will be written as such. Again, next what operation will be performed? You need to make this value as 0. So in order to make that value as 0, you can perform the operation R3 as 4 R2 plus R3. Okay, so 4 R2 plus R3. 4 R2, 4 minus 4 is 0. So you can first write all the, that is first two rows you can write as such. 2 0 1 minus 4 0. 4 R2 is 4 minus 4, it is 0. Then minus 16 plus 7 minus 9, and again last one is like, you can write like that itself, 1 5 3. Okay, now again you can apply what you need to make this row as 0. So in order to make that row as 0, what you can apply, you can make it as R4 is equal to R4 minus R1. So R4 minus R1, what you will write the other 3 rows as such, you write it down. This is 1, okay, 0, 2 minus 4 minus 9. Now R4 will be like R4 minus R1, that is 0. Again 5 minus 5 minus minus 1. 5 minus minus 1 is 6. again 3 minus minus 2, 5. As 3 minus 2 is 1. Okay, 3 minus 2, 1. So this you will be getting. Now you can interchange these rows in order to place this 1 over there. Okay, so while interchanging, you will be getting 1 minus 1, 2, 0, 1 minus 4, 0, 6, 0, 0, 0 minus 9. Sorry, 0, 6, 1 here. Okay, 0, 6, 1, 0, 0 minus 9. Now what you need to do is, you need to make this 6 as 0. Okay, you need to check whether you are able to make this 6 as 0. So for that, apply the operation. R3 is equal to 6 R2 minus 6 R2 minus 6 R2 minus R3. We will be getting 1 minus 1, 2, 0, 1 minus 4, 6 R2, 0, 0, R2, 6 minus 24, 1 minus 25, 0, 0, 9. Now again you can apply like you can change this R3 as R3 into minus 125. So which results in a matrix 1 minus 1, 2, 0, 1 minus 4, 0, 0, 1 and 0, 0 minus 9. So this matrix you will be coming. So here we can see that diagonal elements they are equal to 0 is equal to 1, and the last one this one also we need to make it as 0. So for that you can just multiply, that is R4 will be equal to R9 R1 plus 9 R3 plus R4. So which will be getting it as 1 minus 1, 2, 0, 1 minus 4, 0, 0, 1, 0, 0, 1, 0, 0, 0. So now the matrix it is in row echelon form, and here each column will be representing the variables lambda 1, lambda 2 and lambda 3, and we are having a pivot variable over here in each column. So we can derive equations like lambda 1 minus lambda 2 plus 2 lambda 3 equal to 0. Then lambda 2 minus 4 lambda 3 equal to 0. And finally lambda 3 is equal to 0. These are some of the equations that is derived. So an easy method is like, if each column is having the pivot element, then we can say that the given vectors, they are linearly independent. So how it can be made as linearly independent after solving, that we can see with the help of these equations. So here we can we got the value for lambda 3 as 0. So lambda 3 equal to 0. Substituting this lambda 3. So here three equations are there, no? 2 and 3. Substituting lambda 3 to lambda 2, what you will be getting? Lambda 2 equal to 0. Again lambda 2 and lambda 3, substituting in 1, you will be getting lambda 1 also equal to 0. Okay. So this way you will be able to reduce, you will be able to prove that the given vectors, they are linearly independent.